Hi everyone, welcome to the class. Today we're going to do a little bit on plate tectonics. So what you need to know about plate tectonics is even though we think that the earth is a solid base beneath our feet, it actually is not. These very large pieces of earth are actually moving, changing, destroying, and crashing into each other, all being pushed by magma deep down in the mantle. So there are a couple of different types of plates. There are plates that move towards each other. There's plates that move apart from each other. And there's plates that slide side by side. These are called, they have different terms. The plates that move apart are divergent. The plates that move towards each other are convergent. And the plates that move side by side are transform. The excuse me. Now, these plates have been moving for a very, very long period of time. In fact, the Earth as we know it, the continents as we know it today, are not how they were a million years ago or a billion years ago. They have kept changing over a long period of time. At one point, it is hypothesized, and through a lot of research, they have proven that the continents might have all been one mass. So South Africa, South America, Africa, India, Asia, Europe was all one large continent. Now, due to this movement, eventually it all broke apart. Then they came back together, then they broke apart again. And there's a lot of evidence to support this. This whole thing is called the continental drift theory. And over a period of time now, studying earthquakes and volcanoes, now we know that earthquakes and volcanoes are a result of this movement underneath. A lot of this has been studied through looking at rocks and the magnetism in the rocks, also looking at how rocks, the radioactivity in rocks has disintegrated over a long period of time. That's how you do carbon dating of the different layers of the earth. And that is also how you know which layers match other layers on different continents and different parts. A really good example of this is studying the layers in a place like the Grand Canyon. So if you go to the Grand Canyon, take a look at the layers over there, you can actually see the layers. Now imagine if you see these same layers across continents and the same layers. So now we know that they broke apart at some point in time. When we're looking at divergent plate boundaries, we're looking at how the sea floor is actually spreading and becoming wider. So most of the time we see these divergent plates in oceans. So the mid-Atlantic ridge, which is in the middle of the Atlantic Ocean, over there, it's actually spreading the Atlantic Ocean larger and larger. On the flip side, if we look at what's happening in the Pacific Ocean is actually sinking underneath the South American and different parts of Asia. An example, the Mariana Trench off the coast of Japan is where there's a large amount of this ocean that's just being swallowed into the mantle. Okay, and lastly, we come to transform plate boundaries. Transform plate boundaries are where the boundaries of the plates are actually sliding past each other. I happen to live in California now, in San Francisco. Well, not in San Francisco, on the East Bay. San Francisco is actually on the other side. The San Andreas Fault actually runs very close by, and the San Andreas Fault is where two plates are sliding side by side. Let's say something were to happen in a big way, which hopefully it won't because I live here now. The hypothesis is that one part would move straight into the ocean and the other one would just remain a part of the North American continent. But what's happening is the whole bay is actually sliding side by side each other. And part of it runs to the University of Berkeley. Where I'm at, there's a Wildcat Canyon, but it's actually on the Wildcat Fault. And there's multiple faults, as you can see if you look at the slide number, I believe it's slide number 16 in the plate tectonics PowerPoint. It talks about transform plate boundaries. And if you look at it, you'll see actually broken bits of plates. So, the faults or the plate is not just one solid plate. It's actually really cracked along the edges. So there's a lot of puzzle piece movement happening. If you were to break a piece of plastic, you would notice that it doesn't break across a line that has been kind of dotted out. It breaks in a very non-uniform manner, and this is because the rocks are different underneath the earth. And last but not least, we're going to look at these Hawaiian Islands. And you're probably thinking, okay, if these places along the plate boundaries are not safe, they're full of earthquakes and volcanoes, and where's a safe place to live? Okay, if we go live in the middle of smack in the middle of a continent, that might be safe. However, there are this phenomena called hotspots and mantle plumes. And this is where there are weaknesses in the solid continent itself, where there's pressure building up and a hotspot is created. So the Hawaiian Islands is a good example of a hotspot. The islands are slowly being eroded away while there's new volcanoes erupting, creating new land. And as the oceanic plate moves, it's kind of like this little eruption of lava is going to create new islands as a result of the plate movement. So that's what hotspots are. Mantle plumes are where there might be in the middle of a continent, so not under the ocean floor. There may be another eruption happening, and eventually it comes up. It forms a bubble underneath this continent because it can't break through, but eventually it kind of has to burst out. So if you've ever had acne, you know about it. You might have a little bump which hurts, and over a period of time it comes to the surface and just, you know what happens. So that's what a mantle plume is. And there's a large mantle plume under Yellowstone National Park. So if you haven't been to Yellowstone National Park, go there, because if you look at the rocks, the researchers have studied the rocks in the area, and they've seen that Yellowstone was once a large volcano. They are estimating that it has passed its expiration date of just chilling there, being Yellowstone National Park, and it's due to erupt. So, and if it did, it would be a super volcano. And these do happen. We've had super storms, super floods, super tsunamis, mega tsunamis, and mega storms, mega hurricanes. And with climate change and the changing nature of our planet, these will increase, especially with climate change. It kind of speeds up the process. So these are things to be aware of, and this is why we study the Earth, even though we like to say geology takes a very, very long time. It is not that long. We're at some sort of tipping point or the other. See you in the next class.